right, let's go through and see if you have any questions with this. Were you able to match these up correctly? Oh, my board is not the same. No. Okay, make sure you use like ages of people in retirement. Make sure you use the appropriate ages for that. Yeah, you have to sign in. You have to sign in things.
What?
And none of this is working. Right. All right, Daniel, give me one observation that you made for the first graph. One observation.
Oh, got it!
Facebook is dominant. Is the dominant social network. Okay. The other Daniel, give me one observation you made.
Link is the least visited social network.
Lincoln is the least one. Okay. Anybody else make an observation, Nick?
Like, Pinterest and Tumblr are used the same amount of time.
Okay. They're used the same amount of time. Pinterest and Tumblr, they're used the same amount of time. They're kind of about even. We can also say that, like you said, Facebook is the predominant one. That's well more than the rest. Just like things that you would notice from this. You know, things that catch your eye. What type of graph is this that goes from highest to lowest? Pareto. Good. And see, that kind of catches your eye? Taking the top one, working down, right? Okay, how about the next one? What kind of graph is this guy? A time series. Okay, what's one observation you made, Jada?
2006 had the most thefts.
Okay, 2006 had the most motor vehicle thefts. And Julia, any other observations?
I said it like decreased.
Good. The thefts have decreased in the United States over time. Okay, and Aaron, you have any other observations? Okay, so Aaron gave us a figure. For 2006, he said 1.2 million car thefts in the United States. He pulled out the data right off his chart. These are very good observations. Very good. The fact that we decreased, great observations. Okay, let's look at the next one. This is quite the busy circle graph. How other drivers irk us. Okay. Torrance, you got an observation? Tailgating was the most. Okay, that was like the most annoying thing that irks a driver when somebody tailgates them. Okay, Olga, you have an observation?
Drivers who are too cautious are least irking.
Good. Drivers who are too cautious. Now, in the past, you used to say you're behind the Sunday driver that's slow, that's cautious, and it's not that irking to people. It's good to be cautious. Have more patience when you drive. Okay, let's see. Tess, you have an observation you can share with us?
Tailgating is the most annoying thing a driver can do.
Okay, that we had for tailgating. Any other? Do you see a big one up here?
I just put it on it's higher than 100%.
Did it add up to 100%? Yes, good. Nick made a good observation. It adds up to 100%. Dan?
I said drivers that are too cautious irk us less than drivers that are speeding.
Good, good. He compared the drivers that are too cautious versus drivers that are speeding.
Speed doesn't even hurt people.
And yeah, that doesn't even seem to irk people as much. Yes. Mom, you have an observation?
I said almost a quarter of the people get hurt by people using it.
There you go. That's a very good one. Cell phones, almost a quarter. A quarter would be 25%. That's another good observation. Almost a quarter of the time, people are irked by people using cell phones. This is good. This book is very updated on, like you notice a lot of our data goes up to 2012. So these are very good updated statistics on these. All right, the last one, amount spent on pet care. An observation. Danielle, an observation. People spend the most amount of money on pet food. Good. Nicole, observation?
People spend the least amount on live animals.
Oh, okay. They spend the least amount on the live animal purchase. Anybody else? Rebecca?
I suppose the pet purchasing costs are less than grooming.
The pet purchasing costs are less than grooming. Very good. These are less than grooming. Very good. You can even say, maybe 2 of these make 1 of those, or twice as much. Good. So these are things, again, that you're looking at. Again, what type of graph is that one? It has the bars. Pareto. Good. Pareto is nice. Do you see the advantage of having a Pareto versus when it's up and down? Yeah. In a bar graph like that, you really have no comparison to do an up and down one. You really want to do a highest to lowest. Okay. Let's see if we can. A good stem and leaf. Everybody okay with the stem and leaf? Questions? Compare yours. Did you remember to put your leaves in order? Did you remember to keep them lined up? That's important. So now you can tell who had the most. The scores on the biology, most of the scores were in the 80s. Did anybody fail this biology test? No? Did anybody get 100? What was the highest mark? 95. What was the lowest mark? Good. What was the most frequent? What was the mode?
91.
91. Good. So go for your leaps. See which one repeats the most. There's the ones. 91. Good. Okay. The lifespan of houseflies. Let me just see if this is going to let me do my board. Still on. My board is not on.
The lights underneath the machine.
You're right. It's not on.
But that red light is on.
That red light is on. It should be on.
It's supposed to be green. I have my
Sure.
completed.
Okay, I'll check it out for you. Okay, the lifespan of houseflies, like you always were very interested in knowing this. Here's your dot plot. You can see where most of your data lies, right in here, and for some odd reason we took a gap, and then we had another little section. Everybody good with this? Make sure you still give this a title. You need a title on all your graphs. No matter if they're dot plots, line graphs, no matter what they are, you need a title. The only how I can do this is to shut this thing down and pull it back up again. Oops, I'm on. Nope, I'm not. I heard that. I have terrible eyesight, but I have very good hearing, guys. I had a student one time. This was years ago. I had an A1 student when I was teaching math A1, and she was so annoyed at me all the time. She was always cursing at me under her breath, and she sat way in the back. So one day I kind of repeated what she said out, under her breath. I said, so now you can just sit in front of me and be here. She had said under her, there's no way I'm sitting in front of her, and I'm like, oh, now you're sitting in front of me. So she was like, she could not believe I heard her. Okay, pie chart. A pie chart is a very nice way, and again, it's nice to use different colors. It kind of stands out. What you want to make sure is that 39% actually covers a good, good chunk of your graph. Less than half, more than 1/4 of it. No one's going to measure, so if you kind of just do the big 2 and then realize that your 20 should look like twice as big as the 10. It doesn't matter if you put your 20 and your 10 on the top, on the sides, it doesn't matter. As long as your graph looks reasonable. Everybody can do part over whole. Get your percents. Can you find your angles?
We have to. How do you find the angles?
Your angles, before you turn this to a percent, just take 0.386 and times it by 360. Find your angle.
Oh, we have to.
You didn't have to.
On the test,
You
you
said
want us to when we
No,
make the
probably not.
paper?
I use percent. Pareto, a nice Pareto graph, you can also see that your x-axis is nominal. Those are nominal. We might think it's ordinal because we gave some kind of order to it, but the topics themselves have no order. What made us put it in order is the Pareto graph. So those are nominal entries, not ordinal entries. We just put them in a certain order. Okay, again, make sure you label everything. Everybody good with this? I know you guys spent a lot of good quality time on this. Time series, this is annoying, I realize. Your years, make sure you cut it. Break your graph, start with every year they give you. And don't bring your ends down. Leave it in the middle of your graph. That's fine. Yep, that's fine too. You can use percents, you can use a decimal. Make it a relative frequency graph, almost, well, without the bars. Normally you don't see percents on those, but they gave that percent. This, I like these two questions. Taking another graph and making a different graph out of it. So from the circle graph, you had to make a Pareto graph. Which one do you like looking at for this information? Do you like, these are your favorite seasons. Do you like looking at the circle or the Pareto? The circle? Anybody like the Pareto better? It's individual preference. The circle has a nice display, and the Pareto. What I find myself is if my circles are very close, like 18, 21, 24, they're kind of close, I kind of like the look of a Pareto. It does show me a difference. You do put your percents out here, which makes those pop out a little bit more. But if I was just looking at the sector, I don't really notice that much difference between the 18 and the 21, which is probably why they didn't put them together. The colors are really nice, they stand out. Individual preference for those. And the last one, making a Pareto into a circle. Now, you had to do your part over whole on this. You had to bring this back to a percent. So you had to say, for Friday was 15. For Saturday, kind of like 14. You had to give the numbers here, do the total, and part over whole. 15 over 50, 30%. 14 over 50, 28%. Your circle has to be in percents. You can't put the number. In other words, you just can't say Friday 15. That means nothing to it. You have to use a percentage. Or an angle, but we really like to see a percent. Everybody was good with this? Okay. So let's take a look at mean, median, and mode. And your mean, median, and mode really hasn't changed over time. It is the same exact thing. However, here's the difference. Central tendency. Can anybody tell me what the measure of central tendency means? In your words, what does the measure of central tendency mean? Maybe. What is this word right here? Central, center. Yeah, I want to know. Yeah, kinda, a little bit of all of that. I want to know, where is the true center of my data? I want to know what represents the center part, the tendency, the central tendency. Where does it kind of meet in the middle? Now, we use mean, median, and mode to find what is the best measure to represent the center of my data. Now, it depends what your data looks like. Sometimes we use the mean. And you always had this question from 8th grade and on the Regents, always in the algebra Regents, it was on the Regents, which one is the best measure of central tendency. And no one ever really explained, and I taught 8th grade, and I don't know that I did the greatest job explaining it now that I know everything that I know from teaching statistics. But you need to find what is actually the true representation of your data. If I give a class a test. And I had, here's my grades. Here's my grades. If I'm looking for the true middle of my data, I can do a mean, I could do a median, I could do a mode. And let's make this interesting. Let's put 2 tens here. I could say, well, the one that occurred most often was 10. Is that a good representation of this grade on the test? No, because kids scored a lot higher than 10. I've got 1, 2, 3, 4, 5, 6. I've got 8 entries. Can somebody do the mean for me? How do you do the mean on this data, on the set? Add everything up, divide by 8. So can someone do a quick mean for me? So we know our mode is 10. And we said that doesn't really represent the middle, the center of my data. What does your mean come out to be? 21? 41? 41.8, you said? Okay, so about 42. Okay, if I find my median is the number in the middle when everything is second order highest to lowest. I have an even number. Watch. I come from here to here to here to here. The middle is going to be right here. What comes between 20 and 40? 30. So the median says 30. Look at how different my mean, median, and mode is. I'm looking for the measure of central tendency, the center of my data. Which one would you say is a good representation of the center of my data? The median. In this case, the median. I have a couple nice high grades, but a lot of my grades were pretty low. Look at 5, 6 out of the 8 failed. These two kind of pulled up my mean a little bit, pulled up my average a little bit. They made my average just a little bit higher. But most of my grades were down here in the low end. So if I'm looking for what represents the center of my data, my central tendency, I'm probably going to go with the median. The mode usually doesn't help you because the mode says, well, I had 2 tenths. Does that represent what most kids did? No, that's not the center of my data in this case. So you learned mean, median, and mode, but you never quite understood what the central tendency means. So we're going to spend a lot of time in this part with your measure of central tendency to see where is actually the center of your data. Now, did everybody was able to find that in their calculators? Okay. So your mean is you add up all the pieces, you divide by how many in your sample set. The difference between the population and the sample, no difference. We add them all up, we divide by how many there are. It's just that we use a capital N when we deal with population. We use a small n when we deal with sample. It's the only difference. So if I'm adding things up, I add them up, I divide by how many there are. Okay. The median, you pick the number that lies in the middle. Good? Okay. And the mode, the number that occurs the most, the greatest frequency. If there are 2, it's called bimodal. If there are more than 2, you just keep track of how many modes you have. It could be 10. Doesn't matter. It's just no longer called bimodal, but it's as many modes as you have. Now, do you guys remember how to do this on your calculator to find the mean, median, and mode? So we're going to go to your L1. In this case, we have no L2, but we just have an L1. The unfortunate part is on this computer, I don't have a calculator. So I'm going to walk you through it. Go to the word stat. You're sitting at edit. Hit enter. And in your L1 table, enter all these values. Put the number, hit enter. Put the number, hit enter. We have no L2. L2 is when we have a frequency. So you're going to put this in your L1. When it's done, make sure that you have the right amount. There's 7, so it should say L1 8 with nothing there. Good? Now, you're going to go to stat again, but you're going to scroll over to the word help. And the first one that you're at is one var stat. It automatically defaults to L1, but I like to put the L1 there. If you put this in L2, then you do one var stat L2. This says I have one variable that I'm taking care of here. My variable is whatever this data set happens to represent. One variable. So one var stat L1, hit enter. The X bar is the mean. The MED that you're going to have to scroll down for a little bit is the median. So what's the mean of this data set? 258.57. Okay, here's the rule of thumb for decimals. Rule of thumb. This is important. Your mean, is 1 decimal more than your data. Your averages for class. If I put in all your test grades, I never give you a decimal grade, but your average comes up as 83.5, 92.1. Your mean is 1 decimal place more than your data.
So like it would be 259 on average?
We're going to round it to the tenths. So you had this, so you're going to round this guy to 258.6. Okay? Now, your median is there too. What's your median for this guy? 268 exactly? Oh, for some odd reason, whenever it did this, it bolded this thing. I don't know why. See the difference between this and this? It kind of just like did something to my board. This is my new technology. And your mode you kind of have to watch and find it. But here's an interesting thing. Go to stat. These were in the right order, but say they weren't. Go to stat, go to sort, A, and type in L1. And then hit enter. And it's going to come back and say done. What it does is it puts your data in order. So now you can find the mode. Say you had 50 items, 50 entries, and they were all in a different order. It's a little harder to find the mode out of 50. If you sort A, it sorts it in ascending order. Yeah, it says done. Now go back to your table. Your table's in order. Well, this table was in order anyway. Just go to stat, edit, and hit enter. Stat, well the bad part is this was already in order, but if you had a lot of data, it would put it in order, and then it would allow you to see which ones have the highest mode. So what is the mode of this data set? 235. Okay, so these are your means, medians, modes. Alright, so now I need you guys to find your mean, your median, and your mode. And then we're going to see which one is the measure of central tendency. Sort this to help you find your mode. In fact, sort it so we could actually look at where the center of your data is. Okay, so we sorted this and we put this in order. Can anybody tell me what the mean is? The X bar? 72? Point anything? Okay, check your data. First, make sure you have the right amount in there, and then make sure that maybe something didn't go in as a 5 or something. Just type right over it, enter. What's the median?
75.
What's the mode? Mode. Good. 50, 70, and 100. However many modes you have, you just string them along. Now, the mode doesn't show up. You have to look at your sorted data and say, I have two 50s, I have two 70s, I have two 100s. Isn't it easier to look at the sorted one than at the regular data? As soon as you sort, it kind of puts it in order. So as you're scanning, you know you had two. If you have a three, then that happens to be the modes. Okay. Did you find your mistake, Tamani? Finding it right now, okay. Okay, always check to make sure that you have the right amount of entries in there first. Okay, which would you say is a good representation of this measure of central tendency? Your mean is falling right here, and your median is also falling in between there. Is your mode a good measure of the center of your data? No, the mode we get rid of. Median is good. Is your mean and your median at the same place? Isn't it pretty much at the same place? Yes. So you could use your median or your mean. In the case where we could use the median or the mean, most of the time we end up with the mean. Because people understand the mean of the data, the average of the data, more than they understand the median of the data. So, Aaron, if it's going to fall in the center of my data anyway, that choice is yours. It's pretty much in the same place when this happens. Okay?